In this video, we'll learn how to solve equations that have rational exponents. Now, if you take a glance down here at our examples, this looks like a completely new type of equation that we've never solved before. But we've just learned how to solve radical equations. Essentially, radical equations are just like rational exponent equations, except the notation is different. So let me remind you of a rule of exponents that'll help us make the connection between this new type of equation with the radical equations we just solved. Remember, if I take a number a and raise it to a rational exponent m divided by n, I can write that in radical form. So if I take the denominator of my rational exponent and place it as the index of the radical, and the numerator of my rational exponent, and you can either place that under the radical or outside the radical. A lot of times this one's a little bit easier to work with. Then you've got an equivalent expression. So we've learned how to solve equations like this. I'll give you a real simple example of a radical equation. We solved this by squaring both sides. When we square both sides, it eliminates the radical. And we end up with solution x equals 4. Now, if I rewrite that equation with rational exponent notation, I'm going to follow the same procedure. So let's look at this radical expression. There's no index written, but when there's no index written, we assume it to be a 2. Also, there's no exponent either outside the radical or on the radicand, so we can assume that is 1. So the square root of x is the same thing as x to the 1/2 power. So I could rewrite the equation, square root of x equals 2, in the form x raised to the 1/2 equals 2. That's exactly the same equation, just different notation. Now notice I can solve this equation by squaring both sides, just as I did with the radical. Remember, when you raise a power to a power, you multiply the powers. So 1/2 times 2 gives me 1. I get x to the first power equals 4. So either way, you get the same answer. Ultimately, rational exponent equations are just like radical equations, except they have different notation. So the procedure for solving them is very similar. If you can make that connection, it'll make these a little bit easier to learn. So here's the procedure. If an equation contains a single expression involving a rational or fraction exponent, do the following. Isolate the term containing the rational exponent. Remember when we were solving radical equations, our first step was to isolate the radical, right? Then number 2, raise both sides to the power that is the reciprocal of the rational exponent. Again, relating this to radical equations, we isolated the radical and then we squared both sides or cubed both sides, depending on what the radical was. So that's essentially what we're going to do here, but we have to choose an appropriate power. So raise both sides to the power that is the reciprocal of the rational exponent. That's a mouthful of vocabulary there, but let's look at our example. On our example here, our rational exponent was 1/2, and we squared both sides to solve it. That motivation was from what we knew about radical equations, right? But the relationship between those two numbers is that they're reciprocals. So if I have a more complicated fraction right here, I'm just going to flip it over, make its reciprocal, and then apply it to both sides. And that's going to cancel the rational exponent. Now, one thing you got to watch out for, which I even forget sometimes, if the denominator of this new power is even, this will yield one positive and one negative result. And I'll show you when that pops up on our examples. Once we do that, then we will have transformed from a rational exponent equation into something that we know, such as a linear equation or a quadratic equation. So based on its pattern, we'll solve the resulting equation. And then number 4, check the solution by substitution. And remember, extraneous solutions pop up with these types of equations as well. So let's give it a try. Example 3, solve the following rational exponent equations. So in our first example, the term that contains the rational exponent is already isolated. So my first step is to eliminate that exponent. So I want to raise both sides to the reciprocal of the fraction in the exponent. I've got a 5/3 up there, so I'm going to flip it over and call it 3/5. So I'm raising both sides to the 3/5. Remember, we're doing the same operation to both sides. Then in the situation that you have successive powers, remember we multiply the powers. 5/3 times 3/5 is 1. So we end up with x to the first power. Then we have 32 to the 3/5 power. Now, if I rewrite this in terms of radical notation, the denominator of my rational exponent becomes the index of the radical, the base is the radicand, and the numerator is the outside exponent. So we have the 5th root of 32 to the 3rd power. The 5th root of 32 is 2. And I'm going to raise that to the 3rd power to get 8. Now, please don't panic with all of that arithmetic. Please note that that is very easy to evaluate with your calculator. So let's go back to this step right here, 32 to the 3/5 power. So I'm going to type in the 32 followed by the caret key, and then 3/5 in the exponent, and the calculator does the arithmetic. So we end up with our solution 8. Now let's make sure that that's the correct solution. So I want to take the 8 and plug it all the way back into the original equation and find out if 8 to the 5/3 is equal to 32. So we can just type that into our calculator. 8 raised to the 5/3 does give us 32. So we have the correct solution to our equation. Observe on this example that when we raised both sides to our rational exponent, the denominator was odd. Let's see how it's different if our denominator turns out to be even. So on the next example, we have a rational exponent equation. Before I can apply an exponent to both sides, I have to isolate this term. So I'm going to add 25 to both sides. We have x minus 1 to the 2/3 equals 25. Now we're ready to raise both sides to the reciprocal of that rational exponent. We've got a 2/3 up there, so I'm going to flip it over and call it a 3/2. So I'm raising both sides to the 3/2. Now this is the situation that I have this note of caution about. What I want you to observe is that the denominator that we are using and applying to both sides is even. And this means we're going to have one positive and one negative result. Let's talk about why. So go ahead and simplify the left side. Remember, when we have a power to a power, we multiply the powers. So we end up with an outside exponent of 1, just getting x minus 1. Now over here on the right side, I do want to go ahead and convert that to radical form. So the denominator here is 2, which means the index of our radical is 2. So we're dealing with a square root. 25 is the base, and our outside exponent 3 is going to go on the outside. So observe, we have a square root. Now we know that when you take the square root of both sides, that always gives us one positive and one negative answer. It's just in disguise with this rational exponent. So if your denominator is even, then remember you're going to have two answers there, plus and minus 25 to the 3/2, or plus and minus square root of 25 cubed. Now if I do the arithmetic here, the square root of 25 is 5, and 5 cubed is 125. If you're unsure about the arithmetic, you can simply type in 25 raised to the 3/2 power and get 125. But the calculator won't tell you the plus minus from the equation. That's something that you'll have to remember on your own. So to finish off, I need to add 1 to both sides, and I'm going to put it in front of that 125. So my answers are 1 plus and minus 125. So I'm going to separate it here. We have 1 minus 125 and 1 plus 125. So that's two solutions, negative 124 and 126. Let's check both of those with the calculator. So I'm going to start with the negative 124, and I'm looking at the original equation before I did any work. So I'm going to replace x with negative 124, subtract 1, raise the whole thing to the 2/3 power, and subtract 25. Awesome. That one balances our equation. Let's check our next solution. We had 126 minus 1 raised to the 2/3 power minus 25, and we have 0. So in this case, both of our solutions work. So we'll include both of them in a set, negative 124 and 126. So that one is tricky. Again, watch out for that even denominator. If you have an even denominator, make sure you include plus minus. For odd, you don't have to worry about it. Okay, last example, we have 4x to the 2/3 equals 64. Don't forget the important first step of isolating the expression that has the rational exponent. So the first thing I need to do in this equation is divide both sides by 4. So we end up with x to the 2/3 equals 16. 64 divided by 4 is 16. Then we're going to raise both sides to the reciprocal of the rational exponent. I have 2/3, so I'm going to flip it over to 3/2 on both sides. Now remember, we have the case where we have an even denominator. So that means we're going to get two possible answers, one positive and one negative. So multiplying our exponents here, the reciprocals have a product of 1, and you can type in 16 to the 3/2 with your calculator, or you can think the square root of 16, which is 4, to the 3rd power, which would give us 64. So we have two possible solutions, plus or minus 64. Let's type them into the original and see if they both work. So we have 4 times 64 to the 2/3 power. That gives us 64. And let's check negative 64. And that one balances as well. So we have two possible solutions, negative 64 and positive 64. So like with radical equations, make sure you verify both solutions to disregard extraneous solutions.